lesson. And then once we finish this, you'll be able to do the review with a Google form. The only reason why I didn't leave it as the battleship today was because I wanted you guys, if you really wanted to do battleship, to have the whole class period to do it. Plus, I wanted you guys to do as many questions and be able to do as many questions in class, where I think that the Google form is a little bit quicker than the actual battleship. The battleship, I think, takes more effort, at least based upon when I did the answer keys for them. Okay, so one thing I did not do on the lesson yesterday was I never checked right side and left side limits, right? So when we did limits at a point, I never checked to see if the left and right side limits were equal to each other. We just calculated the limit. The reason why we didn't do that is because there was nowhere where the functions wouldn't have the same limit, right? So I wasn't getting a value of x that I was going to end up with a vertical asymptote, right? Or I wasn't getting a value of x where I knew like it was a piecewise function and there's a chance that they won't be equal to each other. So the only times I check for right side and left side limits to be equal to each other is with absolute value, like these here. Or I check to see if right side, left side limits are equal to piecewise functions. So I have a piecewise function. Or if I had a fraction, right, that I'm not approaching a vertical asymptote. Right, so those are situations where I would check right side and left side limit to see if they were equal to each other before I would go and actually say what the overall limit was. So because I have absolute value, I will check left side and right side limits. So here the limit as x approaches 2 from the negative side of the absolute value of x minus 2. And in this case, there is absolute value. You had an entire section last year in advanced math about dropping absolute value bars. And it was like probably one of the easiest lessons you've done the entire school year, right? It has one purpose in life, and that is to drop absolute values in calculus. That's it. So now I'm going to look here, and I am looking to plug in values of x that are less than 2. So I could have said 1.999, right? Or I could just pick a whole number like 0, right? Pick a whole number like 0. When I plug in 0 in for x, am I bigger than 0 or less than 0? Am I positive or negative? Negative. So when I drop my absolute value bars, I'm going to have negative of x minus 2. And then I totally confused 0 period today by the way that I asked this, but I don't have a denominator, right? So there's nowhere where I could have 0 in the denominator. If I plug in 2 right now, there's no undefined point. So I can go ahead and plug in 2 into my equation, and when I plug in 2 in for x, what do I get? 0. So overall, my limit is 0. Then I can go from the right-hand side, absolute value x minus 2, right? And now I'm plugging in values of x that are bigger than 2, like 3. What happens when I plug in 3? Bigger than 0, less than 0? Bigger, so I can just drop my absolute value bars. And then when I plug in 2, I won't get 0 in the denominator because there is no denominator. So when I plug in 2, what do I get? Overall, just 0. So because these are equal to each other, the overall limit is 0. Left side, right side limits are equal to each other, so the overall limit is that. Questions that you guys have? Yes?
The notation for writing the answer is just 0.
Yeah. Other questions that you guys have? So yeah, you can just write 0 because both the right side and left side limits are equal to each other. So where it gets a little strange is now I am going to have a denominator. So I'm going to look at the left side limit. Oops. So I'm going to look at my left side limit, right? And then, so I'm plugging in values of x that are smaller than 1, like 0. When I drop my absolute value, am I going to have always positive or always negative? I'm plugging in things that are smaller than 1, like 0, so I'm going to have negative. So I have a negative x minus 1 over x minus 1. My x minus 1s cancel out, so I'm left with a negative 1. Then I do my right side limit. When I go to drop my absolute value for my right side limit, I'm plugging in things that are bigger than 1, like 2. So when I plug in 2 in for my x, do I get positive or negative? Positive. I cancel out my x minus 1s. I get overall a positive 1. Because my positive 1 and my negative 1 are not equal, then my overall limit does not exist. Questions that you guys have? So when you guys look at stuff and when I explain stuff to you, if you've not had me as a teacher before, what you don't know is that I have a hard time memorizing things. There's a reason why I didn't want to take any history class with Mr. Canfield. I do not memorize very well at all. So when I describe things to you, it will be kind of strange sometimes, right? So I think I do a continuity definition, and I relate it to like a roller coaster, right? Because I'm trying to find some way of you remembering what continuity is without having to just always memorize the math formula to it. What my hope is that if I gave you something to kind of remember, you'd be able to reconstruct that math formula without it. Okay. Without actually necessarily like word for word, verbatim saying it. So I say that because I look at continuity, like these functions here that I have graphed, right? Which ones are continuous? Well, if I have little Mr. Bug here, happy as a clam because he can walk all over that graph and it is continuous, right? Get as many steps in as he wants. It doesn't make any difference. That function is always continuous. But this graph here, my poor little bug, can't go to every single part of the graph. The only way that the bug can get to the top part of the graph is if he's got a really good vertical and he jumps, right? Right? So what kind of discontinuity is this? This is a jump discontinuity. And I guess we could call it like a falling discontinuity, but we all know what happens with gravity if he was going to fall like that. So in the end, right, the only way that I can get to the other part of the graph is I'd have to jump up, right, if I was walking along the graph. Or I have to really pick up my pencil and move it somewhere else, My pencil has to make that jump. This guy, right? Unfortunately, we decided to put a big hole in the graph, and poor little Mr. Bug here had gravity take into account, and he died. He fell to his death. Goodbye. Goodbye, stupid bug. But because I removed part of the graph and he fell through the hole, he's a removable discontinuity, right? This is what I'm talking about. You're going to be like, what kind of math are we learning right now? Yes.
So would it be the same if the circle was closed too?
If the circle was closed somewhere else other than where the hole is, it is still a removable discontinuity. And then this one is what we call a vertical tangent, which I'll be able to describe what a vertical tangent is in the next unit, but it's because it has a vertical asymptote so no infinity and beyond for this graph and this poor little bug. He can't go to infinity. Infinity is not a number, so I can't have it. So that is a vertical tangent. There's no way that the poor little bug is ever going to get to the other part of the graph. It's just going to keep going and going and going down. Or going and going and going up if they were on the other part of the graph. My other definition that was slightly strange is about a roller coaster, right? Nobody would ever want a hole in the roller coaster for obvious reasons, right? So a continuous function is like a roller coaster from start to end. No gaps, no holes, smooth sailing the entire roller coaster, even though you're screaming your head off until the very end, right? Safe riding for everybody. So, College Board will ask, and we'll always talk like this. When we talk about questions or example problems, I will always try to tell you what College Board will try to do to you. Really, all of this, like this entire school year is like us against College Board. How am I going to get you guys to chip away and get points? Right? How am I going to get you to the end where you chipped away and you've gotten enough points to get a passing score? Which the reality is I need you to get half of it right. I need you to get a good F on the test. You want a 3, I need you to get a good F. If you want a 4, I need you to get a good D. And if you want a 5, I need to get you to a good C. That's realistically where I need you to get to. In the end, I need you to be better than everybody else. It is not about being number 1 necessarily. It's about being better than everybody else, taking the test so the curve is better in your favor. Okay? Because they will always curve their test accordingly. Okay, so what does College Board do? What College Board normally does is they ask you what intervals is the function continuous, right? But I have to define for you mathematically what does continuity actually mean. So first I'm going to take this piecewise function here, and we're going to find right side, left side limits, overall limit, and f at the point. So if and this comes where Andrew's question was really, really good, is that I'm going to look right now at the limit as x approaches 2 from the positive side. So I want numbers that are bigger than 2. Which equation am I going to use? The top one. And so because there's no denominators that's going to give me a 0 in the denominator, I'm going to go ahead and plug in 2 in for my x, and I get 4/3 plus 2, and then I'm super sad that I have to find a common denominator to get 10/3. Okay. Now, Andrew's question was great today because his question was, if I'm plugging in 2, right, into my equation, why am I not using the bottom equation? Why did I use the top equation instead? Okay, and the answer is, when I find f of 2, that is exactly when x is equal to 2. When I'm finding the limit, I'm approaching x equals 2. So it's the function that represents me approaching the number 2, not the actual value of 2. I use the value of x equals 2 to get to what my answer of my y value should be, or it's approaching. But it's not necessarily what happens when x is equal to 2. So there's a difference between evaluating f of 2 and the limit as we approach 2. Those are two separate things. Okay, even though our technique is kind of still the same. Okay. Questions about that? So then I'm going from approaching from the left, right? So I'm going to go less than 2. So I have negative of 2 plus 1, which is negative 1. Because these limits are not equal to each other, the overall limit does not exist. DNE is a common math term for does not exist, which is why we use that abbreviation. Whereas VA is not a universal thing for vertical asymptote, which is why we don't use it. Okay? Even though I would imagine, I don't think College Board would mark you down, you never know. Okay, and then when I want f of 2 is when x is equal to 2. So that is my bottom equation. So I get negative 1. So technically what we would say here is f of x is not continuous. At x is equal to 2. Now, it can be continuous anywhere else except for at 2. And the reason why it is not continuous at 2 is because all 4 of these have to be the same y value. If they're not all 4 the same y value, we're not continuous. Okay, so the true mathematical definition of continuity is that my overall limit as x approaches 2 of f of x has to equal f of 2. And what that means is, here, that overall limit is that the left side and right side limits are equal to each other and equal to f of the point. So all 3 of those things are true, then the function is continuous at that value of x. Otherwise, it's not continuous. Which means in this case, I have different y values at x, so it's a jump discontinuity. Most piecewise functions are jump discontinuities. Most of them. Questions that you guys have? Yes?
We know it's not continuous because all of those are not -1.
Correct. Yes. Yes. So it is not continuous because all of them would have to be -1. Other questions that you guys have? My hope is that this limit stuff is better than when you had it before. Like it's starting to kind of sort of make more sense. I will also tell you, even if you were to fail Unit 0, you can still get a passing score on the AP test. Limits is not as much of a testing point or a building point as the next unit is. So the next unit is actually more important. than this one. Okay, so we got one last one. I already did this kind of with you yesterday about vertical asymptote, horizontal asymptote. You can read it if you'd like. But this is my last example. And this is what College Board asks all the time. And I would venture to guess that if you asked anybody that took the AP test last year, they probably saw it. They probably, at least one of the forms would have had it on the multiple choice. And that is, I want to find the value of x to make this function continuous. So I just defined for you mathematically what continuity means. What does it mean? It means that the left side and right side limit are equal to f of the point. Now, when it comes to these types of questions, if it is on multiple choice, nobody cares about your work. Nobody cares about what notation you do. It doesn't make any difference whatsoever. If you're doing this on a free response test for me, or a beginning question, for example, then I 100% want you guys to use true mathematical notation for it, okay? Which means that your true mathematical notation would be, for this, that the limit as x approaches, in this case 2, from the negative side of f of x has to be equal to limit as x approaches 2 from the positive side. So right side and left side limits have to be equal to the overall limit, which has to be equal to f of 2. Now, if you were on a free response test for either me or for College Board, or you're on my beginning question, and you start here, I, for the most part, don't care what happens afterwards. You can go ahead and shortcut it and solve, and you'd be fine. Okay? What that means is that what I'm looking at, right, just like that last example, all of them had to be -1 for it to work. Where did it fail? It failed with this right side, left side limit. Right? So I actually don't care, because of the way that this is written, I don't care about the other two parts of this. All I care about is this first part. Are my right side and left side limits equal to each other? Right, so all I really care about is that. That's all I care about. So how do I do this limit, right? I could write one more limit step, just so that way nobody gets confused in the room. I can figure out what f of x has to go in here. So the limit as x approaches 2 from the negative side, which would be my bottom equation, right? So that would be 4x minus 5k, has to be equal to approaching from the right, which is my top equation, limit as x approaches 2 from the positive side, 3kx minus 5. So I could go ahead and have now one additional step. You wouldn't actually need this. I wouldn't necessarily need you to show this on a free response or on a beginning question for me. Okay? You could jump to what you already know about limits, which is once I knew what equation I was using, ultimately what I'm going to do is I'm going to plug in 2 in for x, and I'm going to solve for k. So on the left-hand side, 4 times 2 minus 5k. On the right-hand side, 3 times 2, nope, yeah, 3 times k times 2 minus 5. I wanted to make sure the order was right so that nobody got confused. And now what I need to do is solve for k. So I have 8 minus 5k is equal to 6k minus 5. So negative 11k is equal to negative 13. So k is 13 over 11. As weird as it may be. Okay, so we did some computation, right? First of all, any questions about what we just did? Once I get here to 13 over 11, do you understand what this means? What does it mean?
That's where x is
So yeah, so when I take this k, right, and I plug it in up here, what's supposed to happen? Limits are equal to each other and the whole function is continuous. At x equals 2. That's what this number actually means, as terrible as it is, as gross as it is. That means if I plug in 13 over 11 in for my k into this top equation up here, both top and the bottom, and I were to graph my piecewise function, they'll have the same y dot. So I might have an open dot over a closed dot, but remember the closed dot wins. That's what we're talking about. Questions? I am hoping that this is making more sense. Like it's starting to, like, if you were like iffy about limits, right? After doing it in hand, that it's making more sense now. I will always try to get you guys to like see, right? Like what, when we solved, what did we actually get and what does it mean? Right? Because otherwise you'll never know why you did the computations to begin with, so how can you reproduce it? Right? That's the main thing. I don't want you to calculate without having ideas of what happens. Like, why did you get that and what does it actually do? Okay. All right, questions that you guys have?